wavelet analysis itself. Okay, so since this is long, we can speed up your processor or your PC. You know, your PC usually has a number of processors, but they don't use them. You usually use like 2 or 1 when it's not doing any serious work. But you can speed them up. So this package is default package. It's called parallel. So you can call it, and I will choose the number of processors I want to use. That's 8. So make cluster 8, and then I am activating all 8 processors so that my estimations will work fast. Okay, so now we are doing univariate here. Univariate analysis. Remember, univariate, we are looking for where there's a lot of variation or oscillations that can tell us of some activity that happened there. It can tell us of some structural breaks or changes or a lot of volatility. So we want to do bivariate. Okay, so watch this carefully. This is where you may start to get into some errors. Okay, so if you look at this, as always, I want to look at my data points, my name, the names of my data, CP2. I don't need the head again. So names. Okay, these are the data points. Okay, so the argument, the function is analyze.wavelet, analyze.wavelet. Okay, now you need to specify the data frame. Okay, so our data frame is CP2. Now, when you are inside CP2, when you bring the table CP2, then you choose which variable inside that table you want to use. And that should be in double quotation. So ghs.df. So you are saying that we are going to the table CP2 and you want to pick ghs.df to analyze. Okay. So here, what we are saying is that we are using the default arguments. So let me change this to GHS for easy understanding, the GHS. So we want to now decompose and see the patterns in the data using the WaveletComp package. Okay. So now let's decompose. Okay, so let's see. We have decomposed. Now we want to see it. We want to plot it. We said the decomposed series is wv.ghs. So we put that one here. And we want to look at the image, the image of the wavelet transform, wt.image. The ones in double quotations are labels that you are going to give. So if you look here, main PNA, so I'll change that to GHS because it's GHS that we are decomposing. And this is very important. Show.date equal to true. If you move it to false, F, then the date will not show. But for this kind of analysis, you usually want your date to show, your date to show. So show.true, show.date equal to T is important. So now let's see how the image will look like. Okay, first of all, look at the scales that it chose for us. Give us 256 instead of 1024. So by default, it's giving us a number of scales. Too many scales doesn't really help. Now, if you look at the plot, I see that there isn't a lot of activity in the data. So I don't see a lot of activity there. You see that here, there's some small activity. This is actually volatility. Okay, so we have a lot of volatility happening. So we have around 2000, maybe 2015 or late 2014 here. What's happened in late 2014? So you can trace it back and see what happened in late 2014. Okay. But if we go to this one, yeah, this is around the end of 2019, right? Yes. So you can attribute that one to almighty COVID-19. Okay. So that's univariate analysis. You are looking at if there's so much activity in the data. Yeah, so when you are doing your work, you choose which name best describes your plot. So let's choose another variable and see if it shows some activity. Okay, so now before we choose another variable, all the way here, all these things here, I'm giving different ways of doing the same thing. So you can set your limits here. I can set, you see here, I said lower period 2, upper period 512. And since we know that the default has given us 256, we can set 256. Or we can still use 512 and just do 512. See, it will not work. So it's still CP2 and it's still GHS.df. I'm going to transform. Let me transform it. Let me say transform. And then because I'm setting a lot of things. In fact, so I said DT equal to T, DJ equal to G is taking long because now the resolution is higher. So when you are decomposing, there's something you need to note. If I choose different resolutions, I'll get different answers. But the default resolution is from what you call, I think, the Wavelet smoothing. If you read the manual, you realize that the default resolution is the Wavelet smoothing. I think in some of my papers I capture it, so that if everyone uses the same Wavelet smoothing, then you can get the same answer, the same graph. But if someone changes the resolutions, then the dynamics will be a little different. So you see, this is taking long. If you increase the resolution, you take even longer. 516, 256, 516. We increase the scales also. Okay, that's done. So let's see how the plot looks like. Pretty much the same, right?
Yeah.
Yeah, almost the same. I mean, basically the same. So you see the 512, much of the plot in 512 is out of the cone of influence anyway, so it didn't matter. Let's choose another variable like
SA, because it's a deep in market, so you could see
okay, so let's see SA. SA with the default resolutions, SA default. Okay. So what is the name for the SA is what?
.df, yeah.
No problem. So let's try SA and see. SA should give us a lot of activity. Then we can try S&P 500. Okay, so let's look at the image. Not so much, but where the activity is typical of the COVID-19, early 2020. So the market was really quiet until when COVID-19 hit, and realized that in the medium to the long term, the effect of COVID-19 started to die down because the market became settled. But in the short term, where the panic was high, you see, and that's where the activity was. Let's see the S&P 500. Okay. So we move from Ghana, we go to continent, and let's look at the global. Let's see if we can find that. So SP 500, SP 500. What is the name given to it? Let's see this. SP 500.df. Where is it? So SP 500. Okay, now let's look at the plot. Can you see what's happening? It's pretty much the same as the South African market. And that's okay because the South African market parallels the advanced market than they do other African markets. Yeah, okay. So you can go through all the variables and see how they fed over the span of the data set. So this is univariate. So let me show you something for the univariate since we are on the SA, on the SP500. Let's try to experiment with the what is it? Reconstruction. Okay, so it's wv.ghs, right? That's the name we gave. Say reconstruct. So looking at the series as against the decomposed series. So this is SP5. Let's say SP. The reconstruct can just run the line. So you see that we have the original series and the reconstructed series. So reconstructed after the decomposition. And if you decompose and you reconstruct based on the target of the decomposition, you may want to get the original series back. So later we'll look at the signal to, maybe we'll not look at the signal to noise ratio. If your wavelet decomposition takes care of reducing the noise in the market, and you reconstruct, how much of data do you get back and how much of noise is taken out? So this is something like that. So the red one is the reconstructed after the decomposition, and the black one is the original series. And look at the 2020 we showed in the wavelet plots. Can you see the high volatility there? Yeah, the high volatility there. See, that's where there was a lot of heat. So that's the reconstructed series. So you can save it. Then if we run it straight, then you can see some nice graph like this. So it's bwv.ghs. So this is like the evolution of the transform. Depending on the series, some are nicer than this. So you can still see that 2020 early is where there's a lot of activity. If you click again, you have the original series, the reconstructed and the original. Okay. So that's all about univariate. You take one variable, and you go through to see where there was a lot of activity. And you can relate that to the real world, what was happening in the market for us to get that a lot of volatility at those times.